The important thing to do here, where you're encountering looks like a string out factoring problem, is to focus on the target that you're looking for. Okay, we want to find out what x minus y equals. It's kind of a peculiar thing you ask for. But if we look back, we see that x plus y equals 10. So I can substitute a 10 for x plus y. That gives me then the equation that 5 times 10 times x minus y equals 25. Well, 5 times 10 is 50. And if I divide both sides by 50, I get x minus y equals 25/50ths, or 1/2. Focus on your target. It's crucial for problems like this. Remember that a prime number is only divisible by itself and 1. Now, that being the case, prime numbers share characteristics. In this case, we've got two prime numbers greater than 2, and x equals a times b. How many positive factors, including 1 and x, does x have? Well, let's say a and b are 3 and 5. Well, 3 times 5 is 15. So 15 would have the positive factors of 1, 3, 5, and 15. Let's look at 7 and 11. 7 times 11 is 77. So 77 is going to have the factors of 1, 7, 11, and 77. You see, anytime you're multiplying a prime number times another prime number, they're going to create a number that's only divisible by those numbers and 1, and the number itself, of course. So you're only going to have 4 factors when you multiply two prime numbers together. This is another problem, factoring problem, where we've got to focus on our target. We want to know what a plus b equals. Okay, let's look and see. When you have something like this and you're dealing with factors, you're either going to be taking something apart to find out what factors go into it, or you're combining factors. Well, in this case, if we look at a squared minus b squared equals 66, if we take a squared minus b squared apart and FOIL it, we find that a squared minus b squared equals a plus b times a minus b. Well, they've told us a minus b equals 3. So I can substitute 3 for a minus b. That would give me a plus b times 3 equals 66. Dividing both sides by 3, I find out that a plus b, which is what I'm looking for, equals 22. This is another one of those problems where you really have to focus on the target. Our target here is the value of a plus b squared. Well, look at what they give us as clues. They give us a squared plus b squared equals 14 and ab equals 12. That looks a little odd. I mean, ab is kind of a curious thing to give you. So we do what we can do. All we can do with this problem, the only operation we can perform with what we're given here, is to FOIL a plus b squared. When we do that, we get a plus b squared equals a squared plus 2ab plus b squared. Now I see where ab and a squared plus b squared fit in, because when I take this apart, I can say that a squared plus 2ab plus b squared equals a squared plus b squared plus 2ab. Well, since a squared plus b squared is 14 and ab is 12, 2ab would be 24. So I add 14 and 24 and I get 38.